Hi everyone, today we are talking about the greatest common factor and factoring trinomials of the form x squared plus bx plus c. That means there's no number in front of x squared except 1. A quadratic equation is a polynomial of second degrees, usually in the form of fx equals ax squared plus bx plus c, where a, b, c is an element of a real number and a does not equal to 0. Every quadratic equation has two values of the unknown variable, usually known as roots of the equation. The roots of the quadratic are x-intercept. The roots of quadratic equation can be obtained by factoring the equation. So there's a lot of information in there. Picture onto the left-hand side. You should notice there is a square, and then it's always the first term of ax squared plus bx plus c. The exponent should be in descending order, and then it has one side equals 0. Then we take the parenthesis and split into 2. Example number 1, to start off, list all the factors for 72. You start with 1 and find the pairs. Be 72. If you do 2, that will be 36. If you do 3, 24, 18, and 5, you can do it. 6, you can have 12. 7, you can do it. 8 is 9. 8 times 9. And then you do 9 times 8. Oh, when you have number that's flipped, that means you have all your combination. But the very important thing is you have to go down the list from 1, 2, 3, 4, and find your factors. So now we are done. We can just write down the numbers we have. So it's 1, 2, 3, 4, 8, okay, no 7, and then do 9, 12, 18, 24, and 36, and 72. And those are all the factors that will work for 72. That means they all can divide into 72. Try with the example number 2. Here's the answer for example number 2. Going on to example number 3. What is the GCF of 32 and 60? Some of you guys can do this in your head. Greatest common factor, easier for me. So what you're going to do is you're going to do 32 and then 60. And the first thing, pull things out. They both have it in common. So if you just look at it, you can say, oh, they both have 2. You can divide into it. So I'm going to start with that. And then divide by 2. Now 32 divided by 2, that's going to give you 16. And then what you have next is 2 going to 60, that give you 30. Because it's even number, we can try to divide by 2 again. And if you divide by 2 again, because they are both even, you can have 8 and 15. You need to decide, is there any number that can divide into both 8 and 15? Now, since they don't have anything in common, and you are done with your GCF. GCF is just the number on the side when you multiply together. So that's just 2 times 2. And the answer for that is just 4. So your GCF is right here on the side. And then you have to multiply them. And that is how you do GCF. Go ahead, try number 4. For number 4, the GCF is just 2, because once you divide by 2, because they both are even number, you get 26 and you get 91. Now 91 is a little bit harder for you to find the factor. Well, 26 is going to be made of 2 times 13. Does 91 can divide by 2? No, because it's our number. Can it divide by 13? It doesn't, because you get decimal. Therefore, I know they don't have anything else in common. So therefore, the answer is just on the side, be just 2. So that's another way. Example number 4, the GCF is 2, because 2 does not divide into 91 and 13 does not divide into 91. Greatest common factor is 2. Example number 5, the GCF is now with letters, and put x to the 5th, y to the 3rd. I will denote letters they have in common. One of them is x to the 5th, the other one is x to the 7th. Pulling things out, what they have in common is really division. So x to the 5th divided by x to the 5th, that's just 1. So we don't really write down 1 times anything. So that's just left with y to the 3rd, z to the 3rd. And the other side will actually x to the 7th over x to the 5th over its division. You're left with x to the 2nd, or 1-to-1 cancellation. So y to the 6th have nothing to do with the x to the 5th. So I'm going to write it down. Then I'm going to take a look. What else do they have in common? Well, in this case, I have 6 they have in common. So if I have 6 they have in common with the of 3, it's usually the lowest exponent. So when you have a lowest exponent between y to the 3rd and y to the 6th, you're going to pick y to the 3rd. So y to the 3rd divided by y to the 3rd, it cancels out, gives you 1. So 1 times z to the 3rd, that's just z to the 3rd. And then y cancel out with the y to the 6th, that will leave you with the x to the 2nd, y to the 3rd. And your greatest common factor is just the number or the letter on the side. Most of case, that's just going to be x to the 5th times y to the 3rd, and that's just x to the 5th, y to, and there's the answer. And try number 6 yourself. So for example number 6, you can take a look at a to the 4th, b to the 3rd, c, a to the 2nd, c to the 5th, d to the 3rd. I can see I have a to the 2nd. If you guys start to getting comfortable with this, you can pick the letter in every single category if they all have it, and pick the lowest exponent. Notice second power and fourth power. I will pick the lowest exponent. That's usually what they have in common. And then so in this case, if you look at the next line, which is C, this one has a C, this one has a C, but nothing else. So C can come out, and then everything is left over. Now you say, can I do those in one step? Absolutely. I will definitely show it to you in the next few examples. This example number 6, the greatest common factor is a squared c. On to example number 7. Example number 7, when you write it out, you have 48 xy to the 2nd, 60 x to the 3rd. So if you take it out, I'm gonna show you guys. I notice I can probably go in with 4. If you want to do 2 to cut it down, it's totally okay. But I'm gonna try to go in by 4, and that's gonna be 12, and x y to the 2nd power. And then if you have 60 divided by 4, it's going to be 15. And then you have x to the 3rd. And then you can pull out the x. Oh, but you say, Ms. Wilson, can I pull out a 3 also still? Because 12 and 15 also have 3. Okay, so I'm going to do both of them in one step. 3 divide into 12 4 times. And x, because it's division, they cancel out. That's just 1. So you have 4y squared. Then you can say 3 go into 15 5 times. And x cancel out x to the 3rd divided by x. That gives you x to the 2nd power. So you are just doing the numbers and the letters together. If that's okay if that's faster for you, as long you pick up, you can definitely do that. But make sure you pick up everything. They cannot have anything else in common. So in this case, the greatest common factor is going to be 4 times 3x, and it's going to be 12x. And that will be your answer. And so now I would like you to try number 8. So example number 8, the greatest common factor is 2ab. It's exactly the same like what we have done for 5 through 8. Now I want you to take a look at the wording. The wording here is find the greatest common factor. That's all. On number 9, they are asking you to factor. Now the only thing is you are doing the same exact thing that you've done in the previous problem, but the way you're going to write your answer is a little different. So let me show you how that is done. So you have 14x plus 18x squared, and if you want to, you can say, okay, I can take out 2x right away because they both are even number, they both have an x. So that's going to be just 7 and x going to x one time, so therefore it's none left. And then you have 2x going to 18, that's going to be 9. X squared divided by x, that's just x. Notice they don't have any common. Now, when you have factor, you got to make sure you write the numbers, you write the factors on the side, which is in this case 2x right here. And then you're going to put the numbers on the bottom in a parenthesis, 7 plus 9x. It's done. That's where the location of this. 2x goes right here, and 7 plus 9x goes inside the parenthesis. So the difference between greatest common factor, which is what they have in common, and factor, that's the only difference. One of them write down all the answers, one of them just write down what they have in common. Try number 10. Check back with your answer. Number 10, the answer is 9x times 2y minus 5z. And that's how you factor. Now notice I pull out the 3 to start because I noticed they have 3 in common. Then I saw, oh, 6 and 15 have another 3 have in common. So I pull out 3. And then both have x. So I pull out x. When you do anything on the side, because that's the greatest common factor, you got to multiply them. And that's how I get 9x. Then whatever is left over, it's right here. I just put it in the parentheses. Number 11 is a little different. Number 11 is factor out factoring, factor by factoring out the negative of the GCF. So most of the time we do not like the negative sign in the front because we eventually going to factor different stuff. We would like to make sure that's a positive. So to factor out negative is not hard. It's just literally changing everybody's position from positive to negative, negative to positive. So we can write it out like the same thing what we did. Be negative 15 x to the fourth y to the third plus 9 x to the third y to the second z minus 12 x to the third y to the fourth. Now when you do that, what you can do is you're going to take out a negative 1. Now you say, Ms. Wisma, I noticed they all have 3. Can I take out a negative 3? Absolutely. You just have to do a little bit more math in your head. But if you don't want to, I'll show you how the negative 1 works. So notice if you take out negative 1, the negative 15 become a positive 15x to the fourth y to the third. And then the plus sign become a minus sign. So minus 9 x to the third y to the second z, and then the negative sign become positive 12x to the third y to the fourth. And then we go on to do the same way. So that's going to be, you can pull out a 3, you can pull out definitely an x to the fourth, x to the third, x to the third, smallest exponent, x to the third. So I'm going to do that part first. 3 goes into 15 5 times, x fourth divided by x to the third x. Y doesn't have anything, so just y to the third. Then 3 going to 9 3 times, and then x to the third divided by x to the third, that's gone. And then y just comes down, y and z. You have 3 goes into 12 4 times, and then x to the third cancel out with x to the third, that's just 1, and then you have y to the fourth. And then if you proceeded to look at other things they have in common, you notice the y is going to have in common. So if you look at y, what to pick, you have y to the third, you have y to the second, you have y to the fourth. So the smallest one is going to be y to the second. So I'm putting that y to the second. So that's a 5xy minus 3y squared cancel with y squared, just z. And then plus 4 y to the fourth divided by y to the second, that's just y to the second. Now you're going to multiply all the number on the side. That's GCF is going to be negative 1 times 3x to the third times y squared. Okay, so your answer is going to be negative 3x to the third y to the second, and that's just left with 5xy minus 3z plus 4y squared. Try number 12. The answer for example number 12 is just negative 5y times 5y squared plus 2y minus 5. On to the next thing. Factor trinomial of the form x squared plus bx plus c. Now, I want you guys to be really careful with the form. Notice I don't have any number in front of x squared except 1. So this set of factoring is very simple. If you can follow this real quick, you can do this in your head, all right? So in this case, I want you to keep this in mind and saying, hey, this is 1 in the front. So what two numbers, like at the very beginning when we did, what are the two numbers can multiply, give me 1? Well, I want you to write down 1 times 1 gives me 1. Then the next thing I want you to do what we did before in example 1 is name all the factors that gives me 12. So I'm going to start with 1 and 12, 2 and 6, 3 and 4. And the next thing is 4 and 3. So I have all my factors. You are going to put the 1 down here, 1 times 1. And then you are going to try to pick the two numbers when you add them together. For example, 1 plus 12 gives you 13. 2 plus 6 gives you 8. 3 plus 4. Hey, there is a possibility of -7, this one. Now you say, Miss Wisma, how about I don't do the other way, 4 and 3? You can definitely do that, but we just don't want to write it down because it takes too much work. Write down all the ones that has flip combination. I'm going to put down 3 and 4. Now we are going to check. So if you have 1 times 3 is 3, 1 times 4 is 4, and then it's going to be 7. And you said to me, Miss Wiesman, checking this number right here, that's a 7, but right here I have a -7. So what do I do with the sign? Well, we gotta force it to make it same. So what we're going to do is if we do -3 come across -4, will that give me -7? Yes. When the number checked out at the end of adding them, if that works, that means you get your correct combination. And then if you double check -3 times -4. Does that give you a positive 12? Check, that is. So then one last check right now is pretty simple. It's just 1 times 1. Does that give you the 1? Check. Okay, 3 things has to be checked and you got your combination. Really, if you do it a few times, anything with a leading coefficient 1 is really, really simple. So the answer now, very, very important. You have to write it sideways. What does that mean? All right, so the sideways answer is this way. Go across. And why is that? Because it doesn't make a difference. Well, when we start do problems that the leading coefficient is not 1, it makes a difference, okay? So the answer is going to be, if they have an x, use x. If they have y, use y. So it's just going to be x minus 3, x minus 4. And that is your factor. Example 14. You still do 1 times 1, which is for the x. 15, you do 1 and 15, 3 and 5. So anything else. But if you just put down 1 and 1, 3 and 5, you can pretty much and say, hey, I want a positive 2. If I do 5 here and I do a -3, I will get my positive 2. And then 3 times, so therefore, this check, and then I'm gonna check the other one, which is -3 times positive 5, check in with -15. So factoring is done. Answer is writing sideways. X minus 3, x plus 5. Number 15, I also still want to do it with you. Number 15, again, 1 and 1, 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6. If you notice, I want 1, that's just 1 and 1, 5 and 6. Which one has to be negative to give you the -1? And does 5 times -6 give you -30? Check the -1 right here and the -1, they both check. Done. So the answer is going to be x plus 5, x minus 6. Number 16, I want to do it with you is because it's a little tricky. So if you do 1 and 1, like what we did, and you write down your combination 1 and 6 and 2 and 3, there's absolutely no way I cannot get the -2 in the middle. It's because if you do 1 and 1, 1 and 6, there's no way when you multiply this is -6 or positive 1. There's no way. All right, then check the other one. You can rewrite it. How about 2 and 3? Well, 2 and 3 would never give you the gap of -2. So in this case, this one doesn't work. Well, it doesn't work. It means it's a prime. You cannot find any factors to work. Number 17 says, factor out the monomial GCF, then factor the trinomial of the form x squared plus bx plus c. So we are combining the past two ideas together. So to do that is I'm going to factor out things in common first. So that's going to be 2n to the third plus 10n squared plus 12n. And then that's going to be 2n. So that leaves me with n to the second power plus 5n and plus 6. Okay. So when you do that, because it's 12, 2 goes in 12 6 times, n and n cancel out. So now what I'm going to do is I'm going to say, okay, this is the same thing before. This is 1 in front of it, it's just 1 and 1. 6, I'm going to write on the side, so 1 and 6, 2 and 3. Well, which one is the possibility of a 5 in the middle? Well, I'm going to try this. 1 and 6 also give me a possibility, because if I do negative, I can get the 5. But one thing I want you guys to double check is look at here. If you multiply multiply 1 and 6, does that give you negative 1 times 6 give you a positive 6? It doesn't. So that one doesn't work, okay? So now what we're going to do is we're going to say, that one doesn't work. I'm going to try another one. 1 and 1, 2 and 3. And that's going to be 2, and that's going to be 3. Oh, so now, yes, that gives me a positive 5 in the middle. 2 times positive 2 times positive 3 give me a 6. So therefore, I have my correct combination to take care this times this gives you check, okay? And then this 5 and this 5 check. All right, so the answer is going to be 2n in the front and then n plus 2 and n plus 3. 2n right here comes down right there. And the answer across, that's the first one. And answer underneath, that's this one. So now I would like you to try number 18. Here's the answer for example 18. The GCF is 3mn in blue. And the combination I need to get to is positive 4. And when you have positive 4, if you do 4, negative 4 and 8, it will give you a positive 4. And if you do negative 4 and positive 8, it will give you negative 32. And that's why I picked the 4 and 8 combination. And then that will give you negative 4 and positive 8. And here's the answer, 3mn times n minus 4 times n plus 8. That concludes today's notes. Thank you so much for watching.